Welcome to EDU World Space.
Here we have a crane that weighs 3,000 kilograms, and it's picking up a load that weighs 10,000 kilograms. So here's the load from the cable at the end of the crane. The crane is attached to a wall here and is pivoted about this point A, and then there's a reaction force here that's only in the horizontal direction at this point down here, so that it prevents it from rotating. So we have the center of mass of the crane is here. We're told that that is 2 meters from this pivot point. The length from the pivot to where the weight is hanging is 6 meters. And we want to figure out, we're asked to find out what these reaction forces are over here at the hinge and then at the other support here. And we're also given the distance, this distance here is 1 meter. So if we take moments about this point so that these two reaction forces drop out, we get the moment from the weight of the crane, which is clockwise, so we have a negative sign. The moment from the weight of the load, the payload here, also a negative sign, and then the moment caused by this reaction force that has to offset these so that this thing doesn't rotate. So that gives us one equation, and in fact we could use that one right now just to solve for R, because we know everything else in here, and we get that R equals 647 kilonewtons. We also know from a force balance in the horizontal direction that F of X here must be equal to minus R, so that means that's minus 647 kilonewtons. And then a force balance in the vertical direction says that F of Y must offset the total weight of this whole of the crane and the payload here, and that winds up being 128 kilonewtons.